We are here to present a document on web search engine. Before proceeding with the topic web search engine, let's talk about introduction on data structure. Introduction to data structures. A data structure is a way of organizing and sorting data in a computer so that it can be used efficiently. It defines a relationship between the data and the operations that can be performed on them. Why data structures are important? They help in managing large amounts of data efficiently. The choice of the right data structure can improve algorithm performance. They are essential for organizing code, solving problems, and optimizing resources. And let's talk about the types of data structure. Data structure are of two types: primitive data structure and non-primitive data structure. Primitive data structure, these are the basic building blocks and they include the integer, float, character and the boolean. And the second type is non-primitive data structure, and they are the more complex to it, and they are further categorized into linear data structure and non-linear data structure. Linear data structure, they are the elements that are stored in a sequence order. Non-linear data structure, they are the elements that are stored in not stored in sequentially. And examples of linear data structure are array, linked list, stack, and queue. Array has a fixed size of collections of elements of the same type. Stack, it follows the last in first out order, that is LIFO order. Queue, it follows the first in first out order, FIFO order. Coming to non-linear data structure, example has tree and graph. Tree is a hierarchical structure. For example, binary tree, binary search tree. Graph, it consists of nodes, that is vertices, connected by edges, used for representing networks. And applications of data structure. Arrays are used in databases and memory management. And application of stacks and queues, they are used in compilers, task scheduling and undo operations. An application of trees are used in file systems, databases and decision making processes. And graphs are used in social networks, GPS navigation and network routing. Hash tables, they are used in implementing associative arrays, databases.
Web search engine. A web search engine is a software system that is designed to search and retrieve data from the internet. It's an essential tool for finding information online. How search engine works. When you enter a query into a search engine, it uses algorithm to search its massive index of web pages for relevant results. The search engine's algorithm analyzes factors like keyword matching, page content, and links to determine the relevance and ranking of each result. The results are then displayed to the user in a list with the most relevant result at the top. Types of search engines. There are several types of search engines, including general purpose search engine like Google, Bing, and Yahoo. There are also specialized search engines like image search engine, video search engine, and academic search engine. Some search engines are designed for specific industries or regions. Features of modern search engine. Modern search engines have many features that make them useful and convenient. Some examples include autocomplete, which suggests search term as you type, and instant result, which displays result as you type. Many search engines also have advanced features like image and video search, map, and news. Challenges and future direction. Despite their many benefits, search engines face several challenges. One challenge is ensuring the accuracy and relevance of search results. Another challenge is dealing with the vast amount of spam and fake content online. In the future, search engines may become even more personalized and intelligent, using artificial intelligence and machine learning to improve their result. Conclusion. Web search engines are powerful tools that have revolutionized the way we find information online. They use complex algorithms to search and retrieve data from the internet, and they have many features that make them useful and convenient. As the internet continues to evolve, search engines will likely continue to play a central role in our online lives.
Now let's see about relationship between data structures and web search engines. Web search engines like Google, Bing and DuckDuckGo rely heavily on data structures to function effectively and efficiently. Here's how different data structures are used in various components of a search engine. Indexing and storage. Hash tables and prefix of trace are used to store and retrieve URLs and keywords quickly. A hash table allows the search engine to map a keyword to a list of documents such as URLs that contain it. A try enables fast autocomplete suggestions and spell correction by organizing words in a prefix-based hierarchy. Web crawling. Queues are used in web crawlers to manage the list of URLs to visit. IFIFOQ ensures that web pages are crawled in the order they were discovered. Hashtags help to keep track of visited URLs and avoid revisiting the same pages. Rank and relevance. Graphs represent the link structure of the web, where each page is a node and each hyperlink is an edge. Algorithms like PageRank analysis analyze these graphs to determine which pages are most important based on their connections. Search queue processing. Arrays and lists are used to store and process query items. Stacks can be used for parsing complex search queries with logical operators such as AND, OR, and NAT. Autocomplete and suggestions. Tries and heaps are used to manage search suggestions and display the most popular or relevant ones as the user types. Caching and fast access. Hash maps and LRU catchers using linked lists and hash maps are used to store frequent search results for faster access. Thank you.
We are using four main data structures in this program, that is tree, AVL tree, graph and hash table. Let's look at each of these in turn. These are the codes which are used in our example problem. The tree data structure is used to store words and perform quick lookups, such as searching for a prefix in a large dictionary. Here we are used children 26 is the array. This array holds pointers to child nodes. Each index corresponds to a letter of the alphabet A to Z. Here is end of word. This integer flag tells us if the current node marks the end of a word. When we finish inserting a word, we set this flag to 1 to indicate that the word ends here. Then we move on to the AVL tree. An AVL tree is a self-balancing binary search tree. The key property of an AVL tree is that for every node, the difference between the heights of its left and right subtrees is almost 1. And here also we used some variables like key. This is the unique identifier for each node. In this case, it's used to represent a page ID. Then left and right, these are pointers to left and right child nodes respectively, used to maintain the binary search tree structure. Height. This variable stores the height of the current node, which is used to ensure the tree remains balanced. Then we move on to the graph part. A graph represents pages and links between them. Here we are using a simple linked list structure to represent the graph. The page ID variable is the ID of the web page represented by this node. Then the next variable is the pointer links the current node to the next node, forming a linked list of pages. In this context of a web search engine, this could represent the links between web pages. Then the hash table. A hash table stores key value pairs. In this case, it maps page IDs to title or keywords. And the key an array that stores the page IDs, their values, an array of strings that stores the corresponding page titles or keys, and the size variable, the number of elements in the table which is used for hash table operators like lookup and insertion. Now let's discuss the functions used in the program to manipulate these data structures. In the tree function, we used create tree node. This function creates and returns a new tree node initialized with null for all children and 0 for the is end of word flag. Then we are used insert into tree. This function inserts a word in the tree. It traverses the tree, creating new nodes as needed for each character in the word. Once the word is fully immersed, it marks the last node with is end of word equal to 1. Then we move on to the next function, AVL tree functions. Here we used create AVL tree function. This function creates and returns a new AVL tree node initialized with a given key and null pointers for left and right children. The height is set to 1 as a new node is initially a leaf node, and we are used insert into AVL tree. This function insert a new node into the AVL tree. It compares the key and recursively inserts it into the left or right sub. In the graph function, we are used create graph node. This function creates and returns a new graph node with a given page ID and null for the next pointer. Then we are used insert into graph. This function inserts a new page into the graph page by traversing the linked list to find the last node, then linking the new node at the end. Then the hash table function, we are used create hash table. This function creates a new hash table with a specified size. It initializes arrays for keys and values. Then insert into hash table. This function inserts a key value pair into a hash table using a simple hash function to determine where to store the pair.
Let's see about applications of web search engine. Information retrieval. Unlock the world's knowledge with a few keystrokes. Access facts, data, and insights instantly. Second, e-commerce. Find the best deals, compare prices, and discover products globally. Shop smart, shop fast. Content discovery. Explore new blogs, videos, music, and more. Web search is your gateway to endless creativity. SEO, search engine optimization. Boost your voice online. Help your content rise, shine by mastering the art of visibility. Social media search. Connect with the trends and people. Discover the stories, matter, and communities with the growth. Academics and research. Fuel your curiosity. Access journals, papers, and research material from the comfort of your screen. Market research. Understand what people want. Analyze trends, consumer behavior, and competition like a pro. Navigation. Find your way, whether it is a route, a location, or a path to knowledge. Search engine guides you. Job search. Land your dream career. Explore rules, companies, and opportunities tailored just for you. Entertainment. Go down in here. Stream shows, discover games, and dive into a university of fun. Enterprise search. Power your business. Search across your organization to unlock productivity and insights. AI and NLP. Experience intelligent search. Machines understood you better thanks to natural language technology. Security. Stay informed and alert. Search engine helps detect threats, scams, and safety measures. Conclusion. Web search engines are essential tools that empower us to explore, learn, and stay connected in the digital world. From finding instant answers to driving innovations in artificial intelligence, research, business, they are at the heart of today's information revolution. As technology advances, their rules becomes even more impact and inspiring. Thank you for watching the presentation. Stay curious, keep exploring, and let search engines be your guide. Thank you.